Hello, am I audible?
Yes, we can hear you.
So, hello everyone. So, in this tutorial, we will be solving some continuation from the past one, where we have solved the inertial problems based on the linear momentum as well as the angular momentum. So, we have covered till a linear momentum and few problems from angular momentum as well. Now, we will look some more problems based on the angular momentum, where we will find the moments due to the particle inertia. So here we will be doing both force balance and the moment balance analysis, and the difference is here the particle or the system or the blocks will have an inertia in it. That means the summation of force or moment will not be equal to zero. Instead, it will be equal to, or it will be proportional to the linear acceleration or the angular acceleration. Then we will move to the new topic, which is based on the conservation of momentum as well as the impulse, force, and so on. So let's start with the seventh question. So here we have a block A that has a mass m and rest on a surface having a coefficient of friction mu k. The cord attached to A passes over a pulley at C and it attached to a block B having a mass 2m. If B is released, determine the acceleration of A. Assume the cord does not slip over the pulley. The pulley has a approximated as a thin disk of radius r and mass m by 4. So we need to determine the acceleration of block A here. So what we can do, we have three bodies. First we have a block A. We have a disk where the cord is attached to A and B. Then we have a body B. So we can separately analyze all three bodies separate, and we can do the force balance and the moment balance analysis. So first, let's say we consider block A.
And we
We
can
can
differentiate the
differentiate the
forces.
forces.
So
So
this is
this is
my
my
block
block
A.
A.
Now
Now
if I
if I
do
do
the
the
force
force
balance
balance
analysis
analysis
in
in
the
the
horizontal
horizontal
direction, I
direction, I
will
will
get
get
summation
summation
of
of
all
all
forces,
forces,
which
which
is
is
equal
equal
to
to
ma.
ma.
So in
So
the
in the
horizontal
horizontal
direction, we
direction, we
have
have
T
T
minus
minus
mu
mu
k
k
n
n
equals
equals
ma.
ma.
And in the
And in the
vertical
vertical
direction, we
direction,
have
we have
summation of
summation of
force in the
force in the
vertical
vertical
direction
direction
equal to
equal to
ma.
ma.
So
So
here we
here we
will
will
get
get
ma
ma
equal to
equal to
mg.
mg.
So we
So we
can
can
put
put
equation
equation
2
2
in
in
equation
equation
1.
1.
So
So
basically we
basically we
can
can
write
write
equation
equation
1
1
is
is
equal to
equal to
ma.
ma.
This is
This is
my
my
equation
equation
1b.
1b.
So
So
now
now
I
I
can
can
consider
consider
a
a
disk.
disk.
So
So
there
there
is a
is a
tension
tension
T2,
T2,
and
and
here we
here we
have a
have a
tension
tension
T1,
T1,
and
and
there
there
will
will
be a
be a
weight
weight
which
which
is
is
mg
mg
by
by
4,
4,
and the
and the
normal
normal
reaction
reaction
will
will
be
be
Cx
Cx
and
and
Cy.
Cy.
So
So
this
this
normal
normal
reaction
reaction
is
is
there
there
because
because
of
of
this
this
joint.
joint.
So
So
now
now
if
if
I
I
do
do
the
the
force
force
balance
balance
analysis
analysis
here,
here,
so
so
we
we
don't
don't
need
need
to
to
consider
consider
this
this
normal
normal
reaction
reaction
because they
because
are
they are
redundant.
redundant.
So
So
here we
here
have
we have
minus
minus
T2.
T2.
Let's set
Let's
this.
set this.
We have
We
this
have this
direction of
direction of
T2
T2
plus.
plus.
So
So
this is
this
my
is my
equation
equation
3.
3.
Or
Or
we
we
can
can
consider
consider
the
the
block
block
B
B
here
here
because
because
as the
as the
particle
particle
is
is
moving,
moving,
there
there
will
will
be
be
an
an
angular
angular
acceleration
acceleration
in a
in a
pulley.
pulley.
So
So
we
we
can
can
actually do
actually
the
do the
moment
moment
balance
balance
analysis in
analysis
the
in the
pulley
pulley
to
to
actually
actually
determine
determine
the
the
relation
relation
between
between
force
force
and the
and the
angular
angular
acceleration.
acceleration.
So
So
instead
instead
of
of
doing the
doing the
force
force
balance
balance
analysis,
analysis,
if I
if I
do
do
moment
moment
balance
balance
at
at
C,
C,
the
the
summation of
summation of
moment
moment
will
will
be
be
I
I
alpha.
alpha.
I
I
is
is
the
the
moment of
moment of
inertia
inertia
here,
here,
and
and
for a
on a
disk.
disk.
So
So
this
this
is
is
the
the
moment of
moment of
inertia,
inertia,
and
and
my
my
angular
angular
acceleration will
acceleration will
be
be
linear
linear
acceleration
acceleration
multiplied
multiplied
by
by
radius.
radius.
So I
So I
can
can
write
write
this
this
as
as
1
1
by
by
2,
2,
mass is
mass is
1
1
by
by
4,
4,
r
r
square,
square,
and
and
alpha
alpha
is
is a
AR.
AR.
So
So
it's
it's
A
A
by
by
R.
R.
And
And
the
the
summation of
summation of
moments.
movements,
So
so
the
the
moment
movement
will
will
be
be
coming
coming
due to
due
the
to the
force
force
T1
T1
and
and
T2
T2
here.
here.
So
So
it
it
will
will
be
be
T2R
T2R
minus
minus
T1R
T1R
equals
equals
1
1
by
by
2
2
multiplied by
multiplied by
1 by
1 by
4 m
4m
r
r
square
square
A
A
by
by
R.
R.
So
So
on
on
simplification, I
simplification, I
will
will
get
get
T2
T2
minus
minus
T1
T1
1 by
1 by
8
8
m
m
AR.
AR.
T2
T2
minus
minus
T1
T1
equals
equals
ME
ME
by
by
8.
8.
So
So
this is
this
my
is my
equation
equation
3.
3.
So
So
now we
now
are
we are
left
left
with the
with the
block
block
B
B
here.
here.
So
So
if
if
I
I
can
can
only
only
do
do
here
here
the
the
vertical
vertical
force
force
balance
balance
analysis.
analysis.
So it
So
will
it will
be
be
minus
minus
T2
T2
plus
plus
2mg
2mg
equals
equals
2me,
2m,
which is
which is
equation
equation
4.
4.
So
So
till
till
now
now
we
we
actually
actually
gathered
gathered
all
all
the
the
equation
equations
that
that
we
we
obtained
obtained
from
from
force
force
balance and
balance
the
and the
moment
moment
balance
balance
analysis
analysis
from
from
all
all
three
three
blocks.
blocks.
So
So
we
we
can
can
use
use
equation 1,
equation 1,
4
4,
and
and
3
3 So in equation 1, we have given the tension which is actually T1. And in equation 4, we have given expression of T2. So we can put equation 1 and 4 in equation 3. So we can remove tension T2 and T1.
So
So
from
from
equation
equation
4
4,
we
we
will
will
have
have and from equation 1, we have T1 equals MA plus mu K mg. So if I substitute these expression which we will got from equation 1 and 4 in equation 3, so we can actually define the relation between force and the acceleration.
And
And we need to find the acceleration. So I can cancel out mass.
This
This
is
is
should
equal 25 by 8 A.
So
So my acceleration will be 8 by 25 G2 minus mu K. So this is my acceleration. So just to recap, we have given a system where we have two blocks A, which is attached by a pulley, and we have given the mass of that pulley and the mass of block A and B, and we need to find the acceleration of the given system. Now since these two blocks are attached with each other from a cord, the acceleration will be same. The only difference is we have given is the mass and the force. So we considered all three bodies, body A, body B and body C, and we tried to do the moment and force balance analysis. So when we do the force balance, it will be equal to the mass multiplied by acceleration because these are the inertial object. And for the movement balance, it will be equal to the rate of summation of moment will be equal to moment of inertia multiplied by angular acceleration. So we do this force balance and the moment balance in all three, bodies, and we collect the equations, and we collect actually three equations. So we solve these equations together to actually determine the unknown acceleration. So basically, when you have given the multiple bodies, just consider each bodies and do the force and movement balance analysis and try to uh,
use
use
the
the
equation
equation
that you
that you
obtain,
obtain,
and
and
then
then
uh,
uh,
it
it
will
will
those
those
set of
set of
equation
equation
will
will
be
be
helping you
helping you
to
to
find
find
the
the
number
number
of
of
unknowns.
unknowns.
Now,
Now,
in
in
this
this
question,
question,
you
you
need
need
to
to
use
use
some
some
initiative
initiative
method
method
as
as
well.
well.
For
For
example,
example,
when we
when we
consider
consider
body
body
B,
B,
we
we
only
only
need to
need to
do
do
the
the
force
force
balance in
balance
the
in the
y
y
direction.
direction.
We
We
don't
don't
need to
need
do
to
the
do the
force
force
balance in
balance
the
in the
x
x
direction
direction
because
because
there
there
is
is
no
no
motion in
motion
the
in the
x
x
direction,
direction,
and
and
also we
also we
don't
don't
need to
need
do
to do
any
any
moment
moment
analysis
analysis
here.
here.
For the
For the
pulley,
pulley,
we
we
did the
did the
moment
moment
balance
balance
analysis
analysis
because the
because the
pulley
pulley
was
was
rotating
rotating
and it
and it
is
is
rotating
rotating
with
with
some
some
angular
angular
acceleration.
acceleration.
So
So
here we
here we
did
did
only
only
moment
movement
balance
balance
analysis,
analysis,
whereas
whereas
for a
for a
block
block
A,
A,
we
we
did
did
force
force
balance in
balance in
both
both
direction
direction
in
in
Fx and
Fx and
Fy,
Fy
because
because
when we
when we
did in
did in
Fy,
Fy,
we
we
actually
actually
get a
get a
relation
relation
where
where
we
we
got to
got
know
to know
that the
that the
normal
normal
reaction
reaction
equal to
equal
the
to the
height.
height.
So
So
this
this
you
you
so
so
you
you
need to
need to
think
think
about
about
that
that
which
which
how
how
to
to
proceed
proceed
to
to
solving
solving
the
the
questions
questions
when you
when
have
you
a
have a
multiple
multiple
body
body
analysis.
analysis.
But
But
the
the
thing
thing
is
is
remaining the
remaining the
same.
same.
Suppose we
Suppose we
have
have
three
three
bodies.
bodies.
So
So
in
in
all
all
three,
three,
you
you
can
can
actually
actually
uh,
uh,
develop
develop
these
these
set of
set of
equations.
equations.
Now,
Now,
which
which
set of
set of
equation you
equation you
need to
need to
develop?
develop
That
that
is
is
actually
actually
based
based
on
on
your
your
thought.
thought.
If
If
there is
there
a
is a
rotation
rotation
like a
like a
pulley
pulley
or
or
a
a
disc,
disc,
then you
then you
can
can
actually
actually
use the
use the
moment
moment
balance.
balance.
And if
And
there
if there
is
is
only a
only a
sliding
sliding
of a
of a
body,
body,
then maybe
then
you
maybe
can
you
use
can
the
use the
force
force
balance
balance
analysis.
analysis.
And where
And
the
where the
body is
body is
sliding,
sliding,
either it
either
is
it
in the
is in the
horizontal
horizontal
motion or
motion
in
or
the
in the
vertical
vertical
motion,
motion, accordingly
accordingly you
you
can do
can
the
do the
force
force
balance
balance
analysis.
analysis.
So
So
basically in
basically
the
in the
vertical
vertical
motion,
motion,
you
you
most of
most
the
of the
time you
time
will
you will
have
have
only
only
forces
forces
which
which
are in
are
the
in the
vertical
vertical
component.
component.
But
But
this
this
is
is
not
not
necessarily
necessarily
true
true
when you
when you
have
have
a
a
horizontal
horizontal
motion,
motion,
because in
because
the
in the
horizontal
horizontal
motion
motion
you
you
have
have
both
both
kind of
kind
a
of a
force,
force,
vertical
vertical
and
and
horizontal
horizontal
force.
force.
So in
So in
that
that
case you
case you
can
can
use
use
both.
both.
But
But
in
in
all the
all the
problems
problems
you
you
need
need
to
to
consider
consider
only
only
these
these
two
two
expression to
expression to
develop
develop
the
the
set of
set of
equations
equations
for
for
different
different
bodies,
bodies,
and
and
then
then
use
use
that
that
set of
set of
equations
equations
to
to
solve
solve
for the
for the
unknown.
unknown.
That
That
is
is
the
the
main
main
concept here.
concept here.
So
So
any
any
doubt
doubt
in
in
this
this
one?
one?
So
So
if
if
not,
not,
then we
then we
can
can
move to
move to
the
the
next
next
problem.
problem.
So
So
here we
here we
have
have a
a 5
5
kg
kg
cylinder
cylinder
is
is
initially
initially
at
at
rest.
rest.
When it
When it
is
is
placed
placed
in
in
contact
contact
with the
with the
wall
wall
B
B
and a
and a
rotor
rotor
at
at
A,
A,
if
if
the
the
rotor
rotor
always
always
maintains
maintains
a
a
constant
constant
clockwise
clockwise
angular
angular
velocity,
velocity,
determine
determine
the
the
initial
initial
angular
angular
acceleration of
acceleration
the
of the
cylinder.
cylinder.
The
The
coefficient
coefficient
of
of
kinetic
kinetic
friction
friction
and the
and the
contacting
contacting
surface
surface
B
B
and
and
C
C
is
is
zero
zero
point
point
0.2.
0.2.
So
So
as
as
usual,
usual,
as we
as
have
we have
discussed
discussed
before,
before,
we
we
will
will
actually
actually
make the
make the
set of
set of
equation
equation
from
from
the
the
force
force
balance as
balance
well
as well
as
as
movement
movement
balance.
balance. So here we have only one body here, and we can actually apply these two expression in the main cylinder itself. And when we made the set of equation using these two expressions, then we can see what are the unknowns we need to find. So definitely we need to find the angular acceleration, but in order to find the angular acceleration, what are the other unknowns we need to find? So for that, we can use this equation to develop a set of equations for a single body. And to develop a set of equations, we need to draw the free body diagram first.
So
This is my friction force.
So
So the friction is here at the two places. One at the contact places between the wall and the cylinder, and then at the contact between the cylinder and the pulley.
So
So
now
now we can do the force balance
in
in
the
the
horizontal
horizontal
direction.
direction.
So in
So
the
in the
horizontal
horizontal
direction,
direction, it will be due to NE.
It
It will be due to this
friction
friction force 1 to
NA.
NA. And it will be also due to this normal reaction, component of this normal reaction, which is NA sin θ, which is equal to mass into acceleration in the horizontal direction. But we can see that the body is not moving in the horizontal direction, and therefore the acceleration in the horizontal direction is zero. The velocity is also zero in the horizontal direction because it is not moving in that direction. So it is simply zero. Now if I do the same in the vertical direction, so in the vertical direction the contribution will come from this friction force, then this friction force as well, and due to this normal reaction, component of this normal reaction, and due to this weight. Now again there is no acceleration in the y direction because this cylinder is actually attached. I mean it is in contact between this pulley and this wall, so it is also not moving in the vertical direction. So it is zero. So as of now we can see the problem is actually related to the case where the force balance summation of all the forces turn out to be zero, which we have done plenty of cases already in the previous weeks. But unlike here, the linear momentum, or in the force balance analysis. When we do the moment balance analysis, then the summation of moment will not be equal to zero. It will be equal to moment of inertia multiplied by angular acceleration, because the cylinder can rotate and it can have its own angular velocity as well. So if I do the moment balance analysis for the cylinder, the summation of moment will be equal to I alpha, and my I is 1 by 2 m r square. And you can see that the contribution to the movement will come due to this friction force and this friction force. All the other force is actually exerting at a line of action, so it will not contribute to any movement. Only two friction force will continue or till only contribute to the movement. So it will be 0.2 Na, and my radius is 0.125, 0.2 Nb at a distance of 0.125 equals. So we can simplify this equation. So this is our third equation. So we actually generated three equations from force balance as well as moment balance. So using these two, we actually generate three equations. And from equation 3, we can see that in order to find the angular acceleration here, we need to first calculate the normal reactions. And those normal reactions will be calculating from equation 2 and equation 1, which we obtain from the force balance. So first we can write equation 1 here again. So we obtain this relation between NB and NA from equation 1. Now we can write the equation 2. So we can directly put this relation, let's say it's equation 1b into 2. So solving this,
we
we
will
will
get
get
n
n
as
as 51.5
Newton,
Newton,
and
and from this
we
we
will
will
get
get NBS 28.768. So So
we
we
already
already
identified
identified
Na and
Na and
Nb.
NB.
Then
Then
we
we
can
can
use
use
equation
equation
3
3
to
to
find
find
out
out
alpha.
alpha.
So when
So
you
when you
solve
solve
this, you
this,
will
you will
get
get
alpha
alpha
as
as
14.57
14.57
rad per
rad per
second
second
square.
square.
So
So
just to
just to
recap,
recap,
the question
question
is
is
similar
similar
to
to
the
the
previous
previous
question.
question.
Only
Only
difference
difference
is
is
here
here
we
we
have
have
only
only
one
one
body,
body,
and
and
then we
then we
use
use
a
a
standard
standard
procedure
procedure
to
to
do
do
the
the
force
force
and
and
moment
movement
balance
balance
analysis
analysis
to
to
develop the
develop the
set of
set of
equations.
equations.
And
And
when we
when
do
we
the
do the
movement
movement
balance
balance
analysis, we
analysis, we
come to
come to
know
know
that
that
in
in
order
order
to
to
calculate
calculate
unknown,
unknown,
which is
which is
alpha,
alpha,
you
you
need
need
normal
normal
reaction.
reaction.
So
So
from
from
the
the
previous
previous
equations
equations
where you
where
have
you have
done
done
the
the
summation of
summation of
force,
force,
you
you
actually
actually
calculate the
calculate the
normal
normal
reaction
reaction
first,
first,
and
and
then you
then you
calculate the
calculate the
angular
angular
acceleration
acceleration
alpha.
alpha.
So
So
any
any
doubt?
doubt?
If
If
not,
not,
then we
then we
can
can
move to
move
the
to the
next
next
one.
one.
So in
So in
this
this
problem,
problem,
again the
again the
concept is
concept is
similar,
similar,
but we
but we
can
can
see
see
that
that
apart
apart
from the
from the
dynamical
dynamical
concept
concept
where we
where we
have to
have to
use
use
the
the
force
force
balance
balance
and
and
movement
movement
balance,
balance,
we can
we can
actually
actually
also
also
use
use
the
the
kinematics
kinematics
equation
equation
to
to
find out
find out
the
the
unknown
unknown
variables.
variables.
The
The
kinematics
kinematics
equation,
equation,
I
I
mean
mean
that
that
where we
where we
have
have
developed the
developed the
relation
relation
between
between
velocity,
velocity,
time,
time,
and
and
displacement,
displacement,
or the
or the
angular
angular
velocity,
velocity and
angular
angular
displacement,
displacement,
and
and
so
so
on.
on. So in this question, we have given a disc has a mass of 20 kg, originally spinning at the end of a strut with an angular velocity of 60. If it is then placed against the wall, where the coefficient of friction is zero point 0.3, determine the time required for motion to stop. What is the force in strut BC during this time? So as we can see that here we need to calculate the time required, which means that if we have to use the kinematic equations, for example, omega equals omega naught alpha t or omega minus 2 theta and so on. Since we need to find the time, we will be using the first equation. And when we use the first equation, we need to actually calculate the angular acceleration, because this is the unknown quantity here. And only if we consider, only if we found the angular acceleration, then only we can actually find the time required. Now there is another imagination you can do. So at first there is a rotation, angular rotation on the wheel, and you need to actually find the time required when it is getting stopped. So this angular rotation is your initial angular velocity, and it is changing. The initial angular velocity is changing, which means that the angular acceleration is non-zero. And we need to find this angular acceleration because we need to find the time where it gets stopped, which means the initial angular velocity is omega, the final is 0. And there is a change from omega to 0, which means there is a non-zero angular acceleration which is there. So from the kinematic equation, we can actually write the relation between angular velocity and the angular acceleration and time. So this is 0. And you can see this, the angular velocity is equal to alpha t. The minus n is because the speed is decreasing. Now, in order to calculate this angular acceleration, we have to do the usual stuff, where we do the summation of force and the summation of moment, and for the inertial body, it is equals to ma for the force and I alpha to the rotational motion, for the rotational motion. And to do all this summation, we need to first make the free body diagram. So there is a gate. Here we have a friction force. And here we will have a force due to this slider or a strut. So our objective is to first calculate the angular acceleration so that we can use the kinematic equation here to calculate the time required. And to determine the angular acceleration, obviously we need to do the moment balance, because it is only equals to the moment of inertia and angular acceleration, because it will be equal to the moment of inertia and angular acceleration. But when we do the moment balance analysis, we know that it will be coming due to a contribution of these kind of forces, friction forces, weight, and so on. And we also know that not all these forces are known. So first do the force balance.
in the
in the
x
x
direction.
direction. Since there is no motion in the x direction, the ax will be 0.
If
If I do the same in y direction,
and
this is my height,
and
and then
there
there
is
is a friction force. 0 because there is no motion. So from equation 1 we can actually relate the normal reaction to FCB. So in equation 2 also we can actually relate the same. That I can write the normal reaction as FCB sine 30 equal to 0. So now we can find FCB and normal reaction. So this may help us to find the angular acceleration when we will do moment balance. So this is my force FCB. And from equation 1, I will get normal reaction at A, which is 96.55 Newton. Now I can do the moment balance. So the contribution to the force is coming from the friction force only, which is acting counterclockwise around B. And all the other force is in the line of action. For example, it is line of action at B, N is line of action at B. So these forces will not contribute. F is not in the line of action, so it will contribute. So this is my force at a distance of 0.15. This is my moment of inertia multiplied by alpha. My NA is 96.5. So I will get the angular acceleration is 19.3 rad per second square. So I got the angular acceleration. Now I can use this kinematic equation to determine time. So my initial omega is 60. My final omega is 0 because it is coming to stop. So my time will be omega naught by alpha. Which is 3.1 seconds. So the question was similar to the previous one. The only addition is here we use the kinematic condition. So we first do the moment and force balance analysis to find the normal reaction, and then to find the angular acceleration. Then we use the kinematic condition to calculate the time. Or you can also calculate the angular displacement also using this equation. So I need doubt here. If not, then we can start solving impulse and momentum, conservation of momentum question. So basically what happens sometimes the force which is we are putting some external force on the body, and that force is actually depend on time. Or sometimes what happens at a very short interval of time, we actually provide very large amount of force. So in such cases, we need to use the conservation of impulsive momentum equation. We actually need to take into account the force which is varying with time. So we know that the summation of force is equal to rate of change of momentum. Now when we apply the conservation of momentum, this quantity is equal to 0. The rate of change of momentum is equal to 0, which means that my final and initial momentum are equal to each other. So this equation valid when there is no external force which depending on the time, or when there is no impulse which is acting. But when there is a force which is time dependent, or there is an impulse, then I can write the same expression in the component form as like this. So this is my initial momentum and this is my final momentum, and in between I am considering the summation of all forces which are time dependent, or which is actually an impulse. So this term is actually represent impulse or a time dependent force. So if it is 0, then the equation satisfies this condition. So to understand more about this concept, let's start solving questions here. So in the figure, the 100 kg stone is shown is originally at rest on the smooth horizontal surface. If a towing force of 200 Newton acting at an angle 45 degree is applied to the stone for 10 seconds, determine the final velocity and the normal force which the surface exert on the stone during this time interval. So here the external force is applying here for over 10 seconds.
And
We need to determine the normal force as well as the final velocity here. So the final velocity can be obtained by using the same in conservation of momentum here in the x direction, because the stone will actually move in the horizontal plane. So this is my stone. This is my weight. This is the external force. And this is a normal reaction. So if I apply the conservation equation in the x direction, this is my equation. Now first we need to model the impulsive term, because it is said in the equation that force is 200 Newton over the time of 0 to 10 seconds. So I can write this term or approximate this term as F T2 minus T1, which is F multiplied by 10. But this is 0 and this is 10 seconds. And my initial velocity is 0 also. So it is 0 plus F 10 equals M V2. So my force in the horizontal direction is the component of this 200 Newton, which is 200 cos 45 multiply 10 equals M is 100 multiplied by Vx2. So I will get Vx2 as 14.14 meter per second. Now if I applied the same conservation equation in the y direction, then I can actually obtain the unknown force. This is one. So this term is actually a summation of all the forces. So here you actually consider summation of all the vertical forces, and in the above we actually consider summation of all the horizontal forces. So here the multiple vertical forces, which is weight, normal reaction, as well as the component of 200 Newton force, which is 200 sine 45. So my initial vertical velocity is 0. This is my weight, this is my normal reaction, and this is my component of 200 Newton, which I am applying, multiplied by time. So just to recap here, I am doing the summation of force multiplied by delta t, and my delta t is 10 seconds, as we are seeing here. So this is the overall summation of 5 component of force or the vertical force, which is inside this bracket, equals to. So since the stone is not moving in the vertical direction, my final vertical velocity is also 0. So this equation just become the force balance equation. So you will get normal reaction as 840 Newton. So just to recap here, we only use the conservation equation in both the direction. If we use in the horizontal direction, we actually got the final velocity. And when we use in the vertical direction, we can actually able to figure out the normal component of force. So basically the thing is, if you use this conservation equations in both the direction, you can either find the force, or you can also find the velocity. And if you use these equation with kinematic equations, then you can also calculate the time and the relation between the velocity, displacement, and acceleration, and so on. So any question here in this one? So we can move to the next problem. So here the 50 kg block is hoisted up the incline using the cable and motor arrangement shown. The coefficient of kinetic friction between the block and surface is 0.4. If the block is initially moving up the plane at 2 meter per second, at an instant time equals 0, the motor develops a tension which is a function of time, and determine the velocity of the block when time equals 2 seconds. So we need to determine the velocity at time equal to 2 seconds. So basically this is the final velocity. And to calculate the final velocity, of course, we can use a convention directly. But as we have discussed in the previous question, that when we evaluate this term, it requires to write down the summation of all the forces. So first we need to see what are the forces which are acting on the block, and then we can proceed solving for the final velocity. We have a tension, then we have a weight at 30 degree. We have a normal reaction, and we have a friction force. So, and the coordinate system I am considering is so these are the forces which are acting, which means that if we use the conservation equation, we have to consider all these forces in this expression. So here the normal reaction at B is unknown. So if I do the force balance analysis in the y direction, I will have this is my weight, which is acting at y direction cos 30 equals 0. My normal reaction is 424.7 Newton. So now if I apply the conservation law in the x direction, in this term, I need to consider forces which are tension and friction forces, which is mu and b. And we already determined NB here. So in the x direction, I will have so initially my velocity is 2 plus then I have to do the summation of forces. So the tension we have given in terms of time, so we can integrate this expression. So when we do the summation of forces, we will have N equals Fp or T minus Fb equal to 0. So this term we have given in terms of time. So we need to integrate this term. And this term we can actually write as Fb multiplied by change of time. So we approximate this expression as this. But for tension we cannot do that because we have given the tension in terms of time. So we need to integrate in time. So my tension term will be 300 plus 120 root t from time t equals 0 to 2 dt minus Fb multiplied by time 2. My delta t is 2 here. And I can consider the component of weight also in the x direction.
So
This is my weight multiplied by delta t, which is 2 equals m v2. V2 is my final velocity. So on integration we will get 300 t and my FB is U and B. Mu is 0.4 and NB we already calculated, which is 424.7. So my final velocity is 1.93 meter per second. So just to recap, we have just used the conservation equation here to calculate the final velocity. But in order to use that, first you need to consider all the forces which are acting. So we considered first all the forces which are acting, and we found that the unknown force, which we don't have any idea about the normal reaction NB. So we do the force balance analysis to calculate NB first, and then we use the conservation equation, which depends on NB, and we calculate the final velocity from this conservation equation. So in all the questions, first you need to figure out the number of forces which are acting, and to look what is required to be found. Because in the previous example, we saw that we can actually get forces from the conservation equation, or we can actually get velocity, or subsequently the angular acceleration or time. So both things we can actually obtain from using the conservation equation. But in both of these cases, first you need to be sure about the forces which are acting, and how to calculate the normal unknown force. In the previous example, we actually use the conservation equation to calculate the unknown normal reaction. Here we actually use the force balance analysis only. So here also mean you can use the conservation equation to calculate the unknown force, because in the earlier example when we calculate the conservation equation here, we actually come down to a force balance equation, which is just simply this one. And in the next question, we just directly use this one. So any doubt?
Hello.
Yes.
Oh, we are getting the velocity less than the initial velocity. So is it a deaccelerating?
Yeah, there might be a retardation because there is a friction force which is acting. So the velocity expected to become lesser after some time.
So force applied goes on increasing with time.
Yeah, so the main force is applying here is 300 plus 120 root t. And it is not always necessary that the final velocity should be higher than the initial velocity. It's the nature of the velocity is completely depend on the forces which are acting.
Okay. Okay.
Yeah. Plus there is a friction force, so most of the time we should be expecting that the final velocity might be lower than the initial velocity, unless you are applying very huge amount of force in the other direction.
Okay.
Yeah. So let's move to the next question. So here the 200-gram projectile is fired with a velocity 900 meter per second toward the center of the 15 kg wooden block, which rests on a rough surface. In the projectile penetrates and emerges from the block with a velocity of 300 meter per second. Determine the velocity of the block just after a projectile emerges. How long does the block slide on the rough surface after projectile emerges? before it come to rest again, and we have given the friction which is 0.2. So here we have a block and there is a bullet which is traveling. It actually strikes this block, and even after striking, the bullet velocity changes from 900 meter per second to 300 meter per second. And it also so this block actually gains some velocity due to this impact. So the initial velocity of this block is 0, but the final velocity is some, let's say VB2, V block 2, and it is a non-zero quantity. And we need to evaluate that if we start moving at this velocity VB2, since there is a rough surface, there is a friction force which is acting, this VB2 continue to decrease because initially the block is at rest. Then after, due to the impact from the bullet, it start moving with this VB2 velocity. And due to the friction, this VB2 velocity come to 0 again. And how much time it takes to come to 0 again? So this time we need to calculate this time. So to first calculate this final velocity of the block, we can use the conservation of linear momentum, and then to calculate the time, we actually can use the principle of impulse momentum. So first, let's use the conservation of linear momentum here. Which is summation of all momentum initially equals to the summation of all momentum in our final time. And this summation actually represents the different number of particles. So it will be MP VP1. So this is the momentum of the bullet, and this is the momentum of block, initial momentum of block, equals to final momentum of bullet and final momentum of block. Now the initial velocity of the block is 0 here, so this will be not contributing. So it will be 0.2 multiplied by initial velocity of the bullet, which is 900, equals 0.2, which is MP. Final velocity of the bullet is 300. The mass of bullet is 15. And this is my final velocity of the block. So my final velocity is 8 meter per second. Now we need to find a time where the block, which has the velocity of 8 meter per second now, will come to 0 due to the friction force. So this is my block. This is the weight. This is the normal reaction of the block. this is my friction. So now if I use the impulse momentum equation in the y direction, I can write as m v1y m v2y. So there is no vertical motion of this block. So both of these will cancel. And we will have only so it could be represented as a summation of force multiplied by delta t equal to 0. So the forces are so my normal deviation is 147.15 Newton. So if I do the conservation of linear impulse momentum in the x direction, then I can write it as so here my final velocity is 0 because and my initial velocity is 8 meter per second because now the block is moving from 8 meter per second to 0. It is coming to rest and we need to find a time for that. So it will be m ex1 and this force I can write as summation of all forces multiplied by delta t. And the force are the horizontal forces are coming from the friction only. So this is my mu. So my friction force is mu NB. My mu is 0.2 and my ND which we got is 147.15. And my initial time is 0 and final time we need to find. So my time will be 4.07 seconds. So this is my time here. So as I said, we use the impulse momentum equation to determine the force and time here. And we use the conservation of linear momentum to determine the velocity which is imparted from the bullet to the block. Once we get an idea about the velocity of the block, final velocity of the block, then we use the impulse momentum equation to determine the unknowns. So any doubt here? If not, then we can move to the next problem. So here we have each ball has a mass m, and the coefficient of substitution between the balls is e. If they are moving towards one another with a velocity v, determine their speed after collision. Also determine their common velocity when they reach the state of maximum deformation. Neglect the size of each ball. So in this question, we need to find the velocity after the impact, and also we need to find the velocity when there is a maximum deformation. So first we will be using the conservation of linear momentum. And one can see from the figure that both velocity A and B is v, but they are in opposite direction. So it will be, and both have a same mass also. So it will be mv minus mv equals mvb2 plus va2. So this is 0 because this is 0 here. So VB2 equals minus VA2. So one can see that the final velocity of each ball is equal to each other, but they are in the opposite direction. So if I use the coefficient of substitution, which is VB2 minus VA2 divided by VB1 minus VA1, so it will be E, VB2 minus VA2, and my initial velocity was V. So my VB2 is V multiply E, and my VA2 will become minus VE because of this. So these are my velocity, final velocity. Now when there is a maximum deformation, what happens that two bodies will approach each other, and when there is a maximum deformation, then after collision, they will not move apart from each other, unlike in the previous case. What happens after their collision? They stick with each other and they try to move with some common velocity v dash, where v dash equals to VA equals VB. So they have a combined velocity which is v dash, and they will try to move in the velocity of v dash because there's a maximum deformation happening. They will get stuck to each other. So if we use a conservation of linear momentum, then we will have mv minus mv. So I'm using the same equation here, and mass is same and the initial velocity are same. So let me once again write this. And since VB2 now equal to VA2 equals to, let's say, some V dash, so it will be M V dash plus M V dash. So it will be 0 equals 2M V dash. So we will get V dash equal to 0. So this is the final velocity of a deformed object, which means that they come to each other, they collide, and they deform shape here, and then they didn't move. Both the particles come at the rest. They stick at the same position, and therefore the final velocity v1 is 0. So for the case of the maximum deformation, there will be no bounce back actually. So the particle, when they hit each other, there will be no bounce back. Instead, what happens, all the momentum is used to deform into some other, all the momentum is used to get the body deformed. So for the both body, they use all their momentum to deform their body, and then we were need to find the velocity of that deformed bodies, and we found that it is 0, which means they quickly come to rest after they collide with each other. And this condition is only valid when the mass is same, because we saw that at LHS mass is same, velocity is same in magnitude. If let's say velocity is different in magnitude, then what happens at LHS, at here? It will be V1 minus V2. So here my velocities are now different. So it will be VA minus VB. So these are my initial velocities. Then my final velocity of a deformed object will be VA minus VB by 2. So if my velocity would have been different, then you can see that after collision, this body get deformed here, and this deformed body, which is now a one identity, will move in the direction, in some direction with a velocity of V dash, and this is their velocity. And at which direction they will move, it depends on the sign of this, VA minus VB. So if VA minus VB is positive, then it will move in the right direction, and if it is negative, then it will move in the left direction. And above we have solved the special case for the velocity VA equals VB. So what happens, this equation will become 0 because VA minus VB equals to 2 and VA minus VA is 2, which is 0. So this is my V dash. So only for the same mass and same velocity, if final velocity is 0, final velocity of a deformed object, otherwise it will be a non-zero.
Sir?
Yeah.
So since here it is moving together, then why are we getting like velocity of first ball as minus V and second ball as V?
No.
Like in two different directions.
Initially they were not moving at the same direction. So this left hand part is the initial condition of this ball, where both balls are in the different they were separate to each other. Then in the final place, they actually attach with each other. They become a one body and they start moving in the same direction. So this is the final state, which is right hand side. But at the left hand side, they were separate. It is the initial state where they were separate to each other, and when they were moving with a velocity v, but in the different direction. So in the final state only we are actually calculating the velocity. So this velocity is the final state velocity, and these two are the initial state velocity of two separate particles.
Yes, that is v and minus v. No, so first in the initial direction, initial side.
Yeah. So because the
In the
body,
final stage,
yeah.
So
So
what?
what?
Yeah.
Yeah.
yes, sir.
Yeah. Tell.
No, so in the final stage, it will be VA2 and VB2, but VA2 we are getting it as minus V, and VB2 we are getting it as V.
Oh no. So this is for the different case. So the question actually contain two parts. See, this is for the second case when there is a deformation, but the previous part, this is without deformation. This is separate part of the question. So this velocity, these are for the without deformation, and this is when there is a deformation present.
So
these two are the different problems.
Okay, I thought they're the same. So that's why I
No.
got confused.
No.
Got it, sir. Thank you, sir.
Yeah. Okay.
Okay. So okay, then let's stop for today. In the next class, we will solve few. Yeah, Shivang. Yeah. Yeah.
Hello.
Yes.
Actually, last session I asked about the. Did you find anything for?
How do you mean by the conservation of energy and momentum, right? So basically, what happens that conservation of energy. I mean, you cannot always use the conservation of energy to calculate the final state of this collision, because what happens in conservation of energy, when these two bodies interact with each other, then the energy will lose as a heat energy, plus there is some loss of energy due to deformation. So basically there will be a change in internal energy. Now what happens that when you use the conservation of energy, it is very difficult to calculate the force which is depend on the time. For example, this coefficient of restitution can be defined in terms of restitution force divided by deformation force. You cannot actually calculate these forces when you use the conservation of energy. So in order to describe the system, you need a conservation of momentum or linear momentum to define the unknown force or unknown velocity. You can use the conservation of energy as a proxy along with the conservation of momentum, but you cannot use only conservation of energy to calculate the unknown, because it cannot describe all the forces which are acting in the body. It is very difficult actually to describe all the forces by using the conservation of energy alone. So that's why you have to use both conservation of momentum and conservation of energy to write down the forces. And it is not same, like you can have a conservation of two momentum, but at the same time it is not necessary that your energy is also conserved, because it will lose due to this internal energy. So unless you are actually consider this internal energy, there will be no conservation of energy which will take place. And this quantity, this internal energy, it's, I mean, very tedious quantity to consider because it may or may not give information about the motion of a body. Internal energy may not tell you how the motion will change because it completely depend on the internal structure of the body. So this internal energy may or may not explain the final state of velocity. So if you add this part, it will become very difficult actually to determine the final state. So most of the time, if you don't consider this internal energy part, then you can use the conservation of energy for the elastic case, and you can proceed try solving problem. But it is using conservation of energy alone.
Yeah, but yeah, actually, like this, like when there is a collision, except the case of elastic one, there definitely there is some loss, whether it is in deformation or heat or internal energy. Then how we can claim that if momentum is conserved, because at the end
Momentum and
there is
energy
both
both
are
are,
being lost.
see, momentum and energy both are separate quantities. It's not like if you have an energy or
Yeah, but it could be a stimuli.
yeah,
Yeah, but
because
this
see,
here, like
when you because when you actually try to solve problem by conservation of momentum, you don't take consider you did not consider the this internal structure of these bodies. You just consider how there is the exchange of force between them, between these two bodies. So if you are using the conservation of momentum, what you are doing, you are actually try to understand are how the forces from the two bodies are interchanging. But conservation of energy is completely different because there you need to consider this internal change of energy, which has nothing to do with the motion and forces.
yeah.
So these two are very different quantities. Yeah.
Yeah, understood. Means individually their state might change,
Yeah.
but the exchange of forces which is there
Yeah.
can be conserved.
Because this internal change
And
and
this,
it cannot be
yeah,
captured
go
by
ahead.
it cannot be captured by the conservation of momentum. Whatever the change is happening inside the body due to the loss of energy or deformation, it properly cannot be captured by the conservation of momentum. So both are different things.
Okay, and the second thing is like about that if a body is moving, two bodies are moving, but the same body is moving at different speeds, then like forces are balanced. If a car is moving at 30 meter per second and then 60 meter per second, forces are balanced in both the state. But consumption of more there is, yeah, in that case like more there is more consumption of power from the engine. So what is the stimuli behind that? If the forces are balanced,
You means that the summation of force come out to be zero. Is this what you mean?
yeah, because there is a uniform, yeah, means if it is moving with a uniform velocity of 30 meter per second at one time, at another time it is moving with 60 meter per second uniform velocity. If there are in both the cases there are it has a uniform velocity, then forces are balanced.
Hmm.
Yeah. So, but there is a more consumption of power when it is moving with 60 meter per second. So what is the driving force or stimuli which is leading to the consumption of more power?
See, there is no driving force at all.
Forces.
Yeah. So what is happening? This you are saying this summation of forces is equal to zero when it is having a uniform motion. Now this summation of forces is made
Yeah.
of let's say F1, F2, F3, F4. And these forces are due to the various parts of the body, various parts of the car, engine, like from there are thousands of parts, and due to these thousands of parts, they have a forces like F1, F2, F3, and F4, which is equal to zero. Now, in the first case, you
Yeah.
said the uniform velocity is at 30 meter per second, and in the second case, the uniform velocity is 60 meter per second. Now, okay, I can agree that in the second case there might be more power, which is coming out from the engine. But since the force is balanced, what is happens? Let's say one of my force, let's say F2, is now F2 dash, and here F2 dash is greater than F2. One of the forces, let's say my F2, increased in the second case. And since the force is balanced, any other forces like F1 or F3, let's say consider F force, it actually decrease. So the force remains balanced. Force remains balanced. So summation of all these force remains to 0. For example, let's say my forces are 1 plus 5 minus 4, which is 6, minus 2. This is 0. When you increase the uniform velocity, in some cases, this 5 becomes 6. But this 2 will also become minus 3. So see, you can see the final state is same. Summation of force is 0 only. And there is an increment in some component of force, which is F2. But at the same time, there will be a decrement in some other forces because the forces summation of force is 0.
Okay, I'm getting a little bit, but if I just model this car or any vehicle as a simply a block, and I see that there is one driving force in the direction of motion and one is friction. They are the only two forces in horizontal directions, and they are balanced at both the stages. I just ignore the internal forces, whatever they may be, but externally there are only two forces. One is in the direction of motion, and another is friction or is it something
Yeah, so
resisting.
even if you have a
In both the cases, they are equal. Yeah, please.
so you have forces which are associated with the power, and you have friction forces, and both of these are balanced. Now, if the power force is increasing because you are increasing the uniform velocity, and in order to have this force balance, which means the friction force is also, I mean, there is some change in the friction force also.
Friction has no relation. The friction is coming from the road or the place where we are moving. It is not like friction does not depend upon velocity.
Why it should? So for example, let's say you are moving in the bike. Okay, let's say you are moving in the bike. You moving ahead with 30 meter per second. You will find some air resistance. Now, if you move with 60 meter per second, you will find more air resistance. So this air
But
resistance
from the
is,
ground,
it doesn't matter. Both are friction only. It's only that from the ground your wheels will get affected by this force, and in this scenario you will get affected by the force. But in both the cases there will be a resistance. This resistance is different when you have moving with 30 and when you are moving with 60 meter per seconds. It's not only you are increasing the power, it's also there is a change in air resistance as well. I mean, I'm just trying to link.
air is not. No. I'm just saying if there is no air and
Yeah,
the
no.
only source of resistance is from ground.
Yeah, I mean, I'm just trying to relate the example. Like in both the cases, there will be some resistance. Here, the resistance causing by air in the ground. Here, the resistance causing by only ground. But in both the cases, my point is there is a change in resistance. Because in order to have a force balance, there should
Friction
be.
we generally take constant. Like we generally have the ground have some coefficient of friction, and that remains constant. It does not have any relation with velocity.
No, it has a relation when you do the force balance analysis. So you have a friction which you can define by mu n. It is just not this force which is acting. This force is acting along with multiple forces which are velocity dependent. So you have a friction force. Let's say you have this mu n plus forces which are velocity dependent equal to 0. Now this could be your power generating force, or this could be anything. Now you are changing this velocity. What is happening? This term force is changing, and in order to be force balance, this force should also be changed because this Fv is summation of many forces. It could be vertical force, it could be weight, it could be many forces which are acting on the system, and this change in Fv could change this vertical and horizontal component of force, which could change this N. So N in both the cases will be different.
Yeah, if friction is changing, then it's okay. Then there is no doubt. But I think that it remains constant. So it's okay. Okay, so
Yeah.
Okay, then next week we will be discussing about work and energy. Thank you.
Thank you, sir.
Yep.
thank you for that clarifying that out. Thank you.
Yeah,
Yeah,
sure.
sure. No problem.